Jack, are you unmuted? Where are you, Jack? We got to unmute you. All right, now.
5, 4, 3.
Welcome to Janet's Planet, where we're traveling at the speed of thought. Happy Earth Day, everybody. Today is a fantastic day to say thank you to good planet Earth for all of its life-giving properties. And I am delighted to have back Professor Dodd Galbreath of Lipscomb University, who's going to talk to us today about Earth's mimicry. Welcome, Professor Dodd. How are you this morning?
I am doing fantastic. This is my favorite day next to Christmas and my children's birthdays.
Awesome. Awesome. Well, tell us more. We're very intrigued by the word mimicry and what you mean by that. So take it away, Dodd.
All right. So good morning. And I'm really glad to be spending Earth Day with you because you guys are the future and you're going to be inheriting mine and Miss Janet's hard work, and you're going to get to apply your own creativity and your own innovations to the planet. And hopefully we're going to inspire you with the planet's amazing capacity to solve our problems. So let's talk a little bit about Earth Day real quick before I define mimicry for everybody, as Miss Janet asked me. I put this photograph in here specifically for Miss Janet because this was taken by an astronaut on
right.
Christmas Eve.
Bill Anders, in fact,
Bill
everybody.
Anders.
Bill Anders took this, and him and Jim Lovell were arguing a little bit about who was going to get the best camera shot, and William Anders or Bill Anders kind of won out.
That's right. And there's a wonderful quote at the top that I won't read you because I know all of you are really bright and are great readers, but you might notice I added the phrase "and sisters" into that quote because in 1968, we didn't always honor everybody in our quotes. And so we are brothers and sisters that are riding this planet together. And this was the shot that really inspired environmentalism in this country, recognizing that we're floating in space on a very unique spaceship. And we have to live within what it gives us. We can't go out and grab it somewhere else. So this really kind of helped put everything in perspective. So let's talk about mimicry. Merriam-Webster's defines mimicry as a superficial resemblance. And I want you to remember that because most of what I'm going to share with you today involves copying or actually mimicking, trying to come up with an emulation of what the Earth does for us every day in the way that we solve problems. And I'm going to show you some very exciting examples of lessons that scientists and engineers and architects and business people have learned from the Earth. But please keep in mind that we're not as smart as planet Earth. Everything that we do that emulates the planet is a superficial resemblance, according to Merriam-Webster. But the Biomimicry Institute, we're talking about Earth mimicry. The biomimicry folks are the ones who kind of coined this concept originally when they described that life can teach us things. Their definition includes something like an approach to innovation that gives us solutions to human challenges, that emulates time-tested structures and functions and values that the planet gives us. The businesses like to call this copy exact. When people were making the first computers, they had to ramp up production really fast. And so the term copy exact told them that they need to copy things exactly if they're already working, right down to the finest detail. So that's what we're going to talk about today. So I'm going to describe Earth mimicry in terms of all of the spheres of the planet. So everybody raise your hand if you know what a sphere is. All right, good. Like the atmosphere, the geosphere, the hydrosphere, the biosphere, the anthroposphere, which is the human sphere. These are the spheres of the planet that allow different types of structures and functions of Earth's services to us to work. So we're going to focus on biomimicry and then geomimicry, bio meaning life, geo meaning rock, hydro meaning water, and atmo meaning the atmosphere. So this is our first biomimicry example. Janine Benyus, who wrote the book Biomimicry, and I highly encourage you to read that if you get a chance sometime. She talks about life being at work for 3.8 billion years of research and development. So when we learn from life, we learn how to solve problems. This is an example of a human problem involving a high-speed train in Japan. This was the world's busiest high-speed rail line at the time. 4.9 billion passengers have used it since its opening in 1964. An estimated 64 million people use it every day. But what was happening with this train was the first design of the train had a rounded nose. It didn't look long and sleek like you see on the right. It was rounded, and every time it went into a tunnel, it was like putting a plunger in a commode. It was pushing air down a pipe, and it was creating a sonic boom that people could hear 400 meters away, right? That's a crazy distance, right? So the loudest noise actually came from the overhead wires associated with the train as it went by. So the engineer went to nature and found a bird called the kingfisher. And this kingfisher can dive at high speed from one fluid, air, into another fluid, water, and water is 800 times denser than air, right? And it would barely make a splash. And he thought, if that bird can steal a fish out of the water and not make a splash, maybe we can take the bird's beak and apply it to the train and stop the sonic plunger booms, right? And it did. They found out that the train could go faster and that it was able to be very 30-something% more fuel efficient, and it could run at its maximum speed of 300 kilometers per hour. Isn't that crazy? Another example of biomimicry is some scientists decided they wanted to create a paint for buildings that was self-cleaning. So on the left, you see a lotus leaf. A scientist took a microscopic view of a lotus leaf and found out that water droplets could actually stand on these little bumps on the skin of the lotus leaf. And these little bumps on the lotus leaf encouraged the characteristics of water that puddle up on leaves, like when you shake a tree after rain and get your friends wet. You know, those little balls of water that sit on those leaves are accentuated by those little bumps on the leaf. And so they created bumps in the paint, and the water would clean the building as it slid off the side of the building. Copied from nature. Here's an example that
I just have to say, this is mind-boggling. So Judah, for my little friend out there who is the utmost observer, and many of the rest of you are as well, this is what, in fact, this goes to something. I was talking to a great scientist and author, Howard Bloom, and he was saying that when he was 10 years old, two tenets of science really impressed him. One was like, find the truth to the nth degree. The other one was look right under your nose. Look for the things that people pass by every day and possibly take for granted. And there you may find the greatest science, which is what we're really seeing here, Dodd.
Amen. Amen to that. Yeah, it's the planet is not just a place where we live. It's not like a cruise ship. It's a living cruise ship. It's a living orb floating in outer space that provides all these free services and all these free ideas. Now, I never would have guessed that bull kelp could be a model for producing energy. I mean, who would have thought that? You know, you just think about bull kelp kind of waving in the ocean current or ocean tides. If you've ever been to California, to one of their famous aquariums in Northern California, you might have seen these bull kelp windows into the sea that you can see there. That gives you an example of how this grows in nature. But an engineer decided to copy the way the bull kelp kind of float in the tide to generate energy. So every time these devices on the right kind of twist or turn, they create electricity that follows the wire and goes back to the land, and that turns on lights in somebody's home. This is one that I just put in here just for you all. I've never showed this to anybody. I ran across this in a class I was teaching to graduate students the other night. This is a type of life form that lives in creeks. And we know that animals love to define their niche, the place where they feel special, the place where they feel unique. Now, the fundamental niche is the one that we call the place where they like to go if nobody's crowding them out, if they don't have any competition for organisms that are similar to them. So here are two different species of the same type of animal that live in creeks. And when they get in the same creek, they have to realize a new niche. They have to share that habitat, so they compromise for a smaller portion of the stream area. Now, businesses realized a long time ago that their fundamental niche is to create a gas station in one spot and to create a Subway in another spot. How many of y'all have been to Subway? Raise your hand real big. Okay. So how many of y'all have been to a Shell gas station? Raise your hand. All right. So you all know what this is like. So these stations like to have their own place, but guess what? The business people decided to copy the realized niche, and they realized, hey, we could put the Subway and the Shell in the same habitat, and both could survive and both could be happy. I think that's the best lesson for what we're realizing about everything we're going through today, that if we're willing to compromise and we're willing to share, we're going to survive. All right, so you ready to switch to the geomimicry?
You bet we are.
All right, geomimicry is older than life. You know, life has been around about 3.8 billion years, and that's really bacteria and algae is what scientists tells us life started out as. But in terms of geomimicry, we're talking about 4.5 billion years. This is the beginning of the origins of the planet. So the planet was like the third rock from the sun, right? It's this big rock that has slowly created all these systems that we enjoy today. So we need to learn from the geosphere and focus on the geosphere even more so because it has the longest experience. So what I'm showing you right here is a concept called convection. If you were to look under the Atlantic Ocean, you would find that there are there's rock that's rising from the center of the planet that's a little bit denser than Plato because it's being heated by the center of the planet that's almost as hot as the surface of the sun. The center of our planet generates heat, and it sort of melts rock. And as that rock sort of becomes semi-melted, it becomes less dense. And we know from physics and from science that materials that are existing in association with lighter materials and denser materials, gravity is going to pull on the denser materials, and the lighter materials are going to float up. We call this convection. Hot air does this as well. When it becomes less dense, it floats up and the cold air moves down. So rock actually moves up and creates these convection cells that allow the planet to recycle rock inside of our planet. So if we copy that, if we emulate that, actually emulation is better, and apply it to the inside of a tankless water heater. You see all of those pipes, that's actually cut through in the middle. So you can see all the water pipes that are moving through all of those fins, all of those little, what looks like little pieces of paper. It's actually copper. Each of those have heat surrounding them. And so when the water comes through those round pipes, it comes in contact with that heat and we get instant hot water. It's just basically copying convection inside the planet. Another example of geomimicry is what we call thermal mass or insulation. This is a diagram of the Earth that shows that heat from the inside of the Earth rising or convecting up, and then it bumps into a denser rock, but that heat slowly gets transferred into that rock because rocks are not really conductors. Rocks are really fundamentally insulators. But we all know that rocks can get hot. If you've ever sat by a campfire, anybody ever sat by a campfire? Raise your hand. Have you ever accidentally touched a rock by a campfire and felt, oh, that's a hot rock? Well, you don't want to do that. You want to ask mom and dad, is that rock hot before you touch it? But ask them sometime to kind of pull a rock out of the fire and let it cool off a little bit and get them to test it for you. And you'll feel that heat that's been slowly absorbed by that rock. So the planet does that too. It has an insulating colder layer up near the surface and a hot layer underneath. So we use this concept to emulate what we call passive solar heating and passive energy conservation in the construction of concrete buildings that hold heat and air conditioning inside without letting it release. I don't know if any of y'all have one of these metal thermal insulated containers like I have that's got a vacuum air seal in the middle of it. It'll keep ice for 24 hours. This is the same concept that we're emulating from the geosphere. And if you look at the building on the right, you see the blue building, all right? That's a blue building on the right. On the left is another building that's kind of green and yellow and red. The building on the left is leaking energy because it doesn't have thick enough walls. The thermal mass of the building isn't dense enough to hold the heat inside.
Wow.
How many of you all see that little red dot in one of the windows of the blue building? You see that red dot? That's where heat is leaking outside of one corner of one window. Isn't that crazy?
Hey,
Now,
Dodd, we've
yeah,
got a great question, and
yes.
Jennifer Wagaman is always asking great questions. So know that I have noticed that consistently. How hot is the core of the Earth? Is what she wants to know.
It's a little bit hot. It's not quite as hot as the surface of the sun, but it's close. It's extremely hot, and as a matter of fact, it's so hot that we actually can't drill down that far to see what it's like. We probably don't want to drill down that far because we might run into something we don't like. But it's theorized that there is a solid metal core of the planet. When the planet was formed, all of you know that asteroids and meteorites that hit the planet, if you've ever been to a space museum, you've seen these metal looking pieces of rocks. So we know that natural metals exist in space, and the rocky materials and the metal materials collided and formed our planet. And the heavier stuff sunk to the middle, the lighter stuff floated to the outer edges, and the heat inside the planet of all those things bumping into each other got stored inside. And then we have these radioactive elements inside the planet that are decaying, that give off heat as well. And so you have all these different types of accretionary heat and radioactive heat and convecting heat that's radiating out of the center of the planet. All right, so how many of y'all can see the trees in this photograph? Raise your hand. All right, you see those trees in the foreground? Notice the trees are not leaking energy as well. So even the biomimicry is working here as well. So here's an example of thermal mass and circulation where the planet has heat that's trapped underneath, and we're actually pumping that heat up to the surface. And you see those red lines that are going from building to building? Those are former heat plants for the city of Vienna, Austria. All of those plants are burning things. They're burning household garbage waste. They're burning maybe tires, maybe sewage sludge, maybe hazardous waste. But if they bring up heat from the earth, they can stop burning things and use the heat from the earth to reduce the amount of things they have to burn or incinerate to provide heat in the wintertime to the city of Vienna. This is that same city of Vienna, Austria. We're looking from a building that I was visiting at the time that's under construction. And notice you see the little concrete pillar on the right. So this building is being made of concrete or rock-like material. We're emulating the geosphere. And they have lowered the ceiling so that they could capture heat more efficiently inside. And then they put windows in these buildings. Notice how big the windows are so they can let the warm sunlight in as well and use the sun to heat the thermal mass. They put all of the heating and cooling and all the computer wiring and all the water pipes and all the sewer pipes in really narrow spaces because they want to try to capture this heat and this air conditioning very, very efficiently. And they end up with a building that's super energy efficient, almost 90% more efficient than our buildings here in the United States. Here are some buildings in Cobb Hill in Heartland, Vermont that I take my students to see every summer. These buildings have 9-inch walls and they capture heat and air conditioning with these insulated walls and hold it to be more energy efficient. But there's a better home nearby in West Lebanon, New Hampshire that we visit that has 18-inch thick walls, 18 inches. And so that insulated wall is what holds that heat in. And it's copying emulating the fundamental functions of the geosphere. All right, so this is just an example of the different things that use energy. Notice how much a heat pump uses compared to, say, a dryer on the far side, or even a washer. All right, so you're ready to switch to hydromimicry? All right.
Yes, this is blowing my mind. I mean, yes, I knew that we copied stuff, but this is amazing to put it in this context.
It is really crazy, and you know, I'm really blessed that I get to teach students Earth systems first before they learn about renewable energy and green buildings and electric cars, because I learned when I was teaching this class that there are fundamental earth lessons that have been used that we're not giving the earth credit for. We're not telling people that these ideas are coming from earth. We're kind of giving ourselves credit for it, when in reality, it's this amazing spaceship that we're riding through space. So let me put things in perspective. Water is really, really important on our planet. You see that big marble that looks blue there on the surface of the planet? That represents all of the water on and in and above the earth, all the water. Isn't that kind of fascinating? Now, what that tells you is that Earth is so big in its mass, it dwarfs the amount of water that exists on the planet. So for example, if I gave you another analogy, it might make more sense. We call the thin surface layer of the Earth the crust. If you were to take a basketball, a regulation basketball, and cover it in dust, that would represent miles deep of the Earth's crust. So that tells you how big the planet is. It makes everything on it look small, even though we know the oceans are huge, right? So here's this is why I want to make this point to you. You see that tiny blue dot? There's 3 dots. There's a big blue marble, a small blue marble, and then there's a blue dot. That tiny, tiny blue dot is all the fresh water on the planet.
Wow.
Compared to the size of the planet. So the folks at the United States Geological Survey came up with this image to help us appreciate fresh water in lakes and rivers, because that's about the only place we can access it easy. All right, so that kind of puts it in perspective.
Can
So,
I ask a question before
yeah,
we move on? Can you go back to
yeah,
that slide?
yeah.
You know, we always say that it's like 70% of our world is water. So
Mm-hmm.
is that just on the top of
That's
all of
just
the,
the surface. Yeah, that's
just the
just the surface.
surface?
Yeah,
Okay.
yeah, that's a great question, Ms. Janet, because one of the things I learned is that because we can't drill into the planet, we don't have drills that are long enough to go deep in the planet so we can understand it. So most of what we use as language to describe what we know about the earth is just about the surface. And because we use that language every day talking about the surface, we forget about the larger world that's beneath us that we don't know, that we know very, very little about. Okay, so why in the world will we have a tree? Are any of you all tree huggers?
Yes, yes, yes.
This is why everybody should be a tree hugger, because trees are amazing water managers, and we want to mimic what trees do. We want to emulate what they do. So a lot of people don't know that the top of a tree and the top of all the bushes that grow under trees detain water. And the reason I remember this term so well, Ms. Janet, is that sometimes I had to go to detention when I was in elementary school. And the great thing about detention is they let you go home at the end of the day. You only had to spend an hour or so in detention, and then you got to go home. Well, that's what trees do. Trees have detention in that they detain water, and then they let it go on its way. They don't hold it overnight. They just kind of hold it and release it. So this delay is what causes floods to be much smaller out there in our natural world, even in cities. This is why we plant trees in cities, because we want to detain that water before it creates that big flood. But the most important thing that trees and understory plants and wildflowers and native grasses that have really deep roots, trees have kind of shallow roots, but store a lot of litter that creates a spongy humus layer. We want this spongy humus layer to retain that water. So when you go home, your parents retain you overnight, right? Or they retain you on vacation for a week or two or for a weekend. You don't want to detain things that you need. You want to retain things. That's our savings account. So we want the savings account to be full and rich. So this is what trees help do for us. The other exciting thing that we're learning is that big corporations like the former Sears and Roebuck corporate headquarters near Chicago, they create these spongy landscapes that capture water so they don't have to mow it all the time. And then we have others who create these beautiful spongy landscapes around their other corporate headquarters, and they change colors with the season, and they release oxygen for us to breathe, and they filter the water, and they provide homes for things that sing when we want to hear something magical outside. And then sometimes they put them on the roof. They create what we call a green roof. There's the Gap headquarters on the bottom right. They put endangered plants on the roof, and now they don't hear the airplanes flying over anymore because it insulates the roof from airplane noise. The building on the top right is the Ford Motor Company. They saved $35 million in compliance costs by having a roof that was spongy. So this is another example of hydromimicry from Nashville. Sometimes you can make a parking lot act like the spongy retention layer of a forest. Isn't that crazy? That's the mayor of Nashville in that blue shirt and that yellow tie. And why is he not running away? There's 1,000 gallons of water coming out of that fire truck and nobody's running, right? Because it's soaking into the pavement. You could not do that on a traditional parking lot. So this is another emulation of the natural absorption layers that nature does for us every day. So we're replicating that in a parking lot in Nashville, where actually building contractors come to get permits so they can learn how to do it too. This is one of my favorite pictures. So some of you may be from Nashville or may live in Gatlinburg or go to Gatlinburg, Tennessee, but there's a restaurant called the Pancake Pantry. And right outside the Pancake Pantry, when you're waiting in line to go get pancakes, they have this porous layer next to the street between the sidewalk and the street, which allows people who are standing, everybody stands in line for Pancake Pantry because they're so amazing, even on a rainy day. And I asked the restaurant managers, I said, why did you all put porous paving outside your restaurant? You're not in the water business. They said, we want our customers' feet to stay dry while they're waiting to get our great pancakes in the rain. All right.
That's awesome.
So this is a building in Paris. You know, who would have thought you could get this crazy, right? That's me at the bottom of the picture with my son and daughter. My very intelligent wife took this photograph, but this building is covered in soil and plants with roots that live on the side of the building and that behave like a tree. This is right beside the Eiffel Tower. So if you ever go to Paris and see the Eiffel Tower, ask to go see the cultural museum that's covered in plants. This is a building in Japan that is mimicking a mountain. You see it there in the middle of all that concrete and all those rock buildings. So when we take a closer look, you see they even let you walk up staircases in this building that mimics a mountain. And inside of this building, they have offices, they have parking garages, they have lots of places where they can do work, but the outside of the building is soaking up water and releasing oxygen and creating habitat. And it looks like a park instead of a big building with no place to play next to a river that needs spongy landscaping to keep the river healthy. Now they have a building that mimics a mountain forest.
Hey, we've got a great question coming in. This is from Jack from Colorado. He says, if everybody took a drink of, well, he's saying of the ocean, if we could drink salt water and not harm us too much, I guess we could do ocean and then we could do fresh water. If everybody took a drink at the same time, 8 billion people, would the ocean level drop a centimeter or a millimeter?
Oh, I have no idea. I'm not that smart, but I will tell you that the Great Lakes in North America represent 20% of the world's water supply. 20%. That's like 20 glasses out of 100 glasses, right? So,
Jack, you just come up with your math problem for today. You got 8 people. You're going to have to find out how much fresh water and how many ounces and all that kind of stuff. So you'll get back to me.
Yeah. And the reason I mentioned that is that years ago, when I was talking to legislators in the state of Tennessee, I was trying to convince them to get worried about the oceans dropping or rising, or to get worried about Atlanta taking water out of the Tennessee River and taking water away from us. And the example that I was able to give them that made sense to them was that if 20% of all the world's water exists in the Great Lakes, and someone could start drinking water out of the Great Lakes faster than it could recharge itself. What did that say about the little bitty Tennessee River? You know, so you're right. It's the bigger the scale that you get with the ocean, the harder it is to pull it down. But the amazing thing is that every time that we lose glaciers on this planet, sea levels rise because water moves from the land to the ocean. Every time we get more ice on the land, more glaciers on the land, sea level drops because water moves from the ocean to the glaciers. So you're right. It's hard to measure how much we could drink it out or suck it out because it's such a big volume of water. But we know that the natural ebb and flow of water movement in nature does create major change. So if that can create major change, maybe we should think about the major change that we can create. And that may not be in our best interest. All right, so, oh, I forgot to mention this building. This is a green roof building in Indonesia. I think it's their Academy of Sciences. All right, so I'm gonna show you another one outside of Atlanta. This is where I was born. The purple star represents the community of Serenbe, Georgia. Serenbe, Georgia decided that they would approach hydromimicry differently. So they had all this beautiful farmland. The orange dots represent places where they thought they could build villages and not develop the rest of their community. And so when they thought about this, they said, hey, if we develop everything, we're going to have 30,000 homes. If we just develop these in these little orange areas and limit the development to a really dense development, we can get 38,000 homes. We can get 8,000 more homes for less farmland and woods that are developed. And so they decided to come up with this hydromimicry system where they recycle water in this constant flow. And then from the air, if you were flying over it in a helicopter or a plane, this is what you'd see. You'd see the villages tucked away in the middle of the forest, but you see mostly forest and mostly farms. And when they do this, they prevent water from running off and creating bigger floods. Look, they even protected the trees around the edges of the concrete footprints of the homes. You see that little green bathroom there on the right? That's actually an outdoor bathroom, by the way. But look how hard they're working to protect the trees, even around the foundation of the houses. And they preserve the meadows, and they raise the sidewalks up in the air so the grass and nature can live under the places where we walk. And so water can soak in. And then they protect the trees that are already there with these fences. Notice how far the fence is away from that big tree, because not only are they protecting the tree, but they're protecting its roots that grow out from the tree. And one city decided to put a dollar value on each individual tree, and they appraised this particular tree at $28,000, because if someone hit it with a bulldozer and killed it, that's how much it would cost the city to replace what that one tree does in the city's water management system. All right, you ready to talk about atmomimicry? I think this is the coolest one, and we're almost done.
The word.
Atmomimicry is just copying the way air moves in our planet. The image on the left is kind of my pet peeve. Every time I see an image of the wind currents on the planet that don't show the atmosphere and the way it exists truly, I get really irritated, because I'm like, they're not giving the Earth credit for what it really does. So the image on the right is the more correct version. So you notice how the atmosphere is kind of bulging in the middle. Like when I get older, I kind of bulge in the middle too, you know, and I start losing hair on the top. But what's going on with the planet is cold on the top and cold on the bottom, right? Because that's where the sunlight hits it the least because of the angle that it orbits around the Earth, its axis. But at the equators, where that sunlight is intensified, the air gets hot, and so it expands. So our atmosphere is expanding. What you're seeing there is we just kind of carved away the atmosphere so you could see the wind movements over the land and over the oceans, but the atmosphere exists above all of that. And so how do we mimic that? Mimicry is actually not copying, it's emulating. Copying is kind of superficial. So I'll straighten. I've been saying that too much, so I won't say that anymore. But somebody decided to build a shopping mall in Africa where it's really, really hot. It's called the Eastgate Center shopping mall. Their temperatures here can get really, really hot during the day, if you know anything about Africa. So they decided to copy a termite mound. You see that termite mound on the left? That's actually 8 feet tall. That's an 8 foot tall. That's 2 feet taller than I am. So
Question before
yeah,
we move too much on, I like to get some things.
yeah.
Again, my friend Victoria wants to know, how do they get the plants on the building?
Oh yeah, yeah. They create a skin that that will hold dirt vertical, very similar to what happens when you see dirt on the side of a mountain and plants growing on the side of a mountain on top of rock. It's a human created, mimicked environment. It's not a complete functional example of what a mountain does, a steep mountain does, but it works well enough to have shallow rooted plants that can grow on the side of a building. I can't tell you exactly what it looks like, but if you Google the cultural, it's actually called Musée, M-U-S-E, I think D-E, D, Branly, B-R A-N-L-E-Y, Musée de Branly. Branly is the street that it's on in Paris. So Musée de Branly. If you Google that, you could probably find more specific pictures of how those plants are held on the side of that building. But it's essentially emulating what happens in nature. Okay. So
and I've heard too that there are, like, even when say our friend Mike down at Grow Wild Nurseries,
yeah,
working with a few companies downtown Nashville, they have to also have a strong enough structure on a roof that supports the weight of
yeah.
the extra water and the dirt and the plants. So there's also some architectural things they have to put into place to be able to hold and support that weight, Victoria.
That's right. That's right. And they've also found out that when they put a green roof on a traditional roof, it makes the roof last 3 times longer because the sunshine tends to slowly break down that rubber membrane on the top of the roof that keeps the water out, that is often baking in the sun.
Awesome. Thank you so much, Victoria. Thanks for asking that question.
Yeah. Sorry, I don't have an example of those things to show you. The engineering details are always more slides than I can imagine you'll be interested in. So here's an example of that termite mound. Remember that termite mound here that's 8 foot tall? That's a picture of the inside of the mall on the right, by the way. Okay, so there's the termite mound on the left, the inside of the mall on the right. Notice those are like people termites inside of that mall. Isn't that crazy? So one of the things they did was they copied the way air moves. Now the point is this is Africa. They can't afford to buy enough air conditioning to keep a building cool. So they decided to copy what termite mounds do in Africa. And termite mounds use convection. Remember we talked about how materials, all matter, all gases, all solids, all liquids, when they are heated, their molecules get excited. They start vibrating, but gases actually start moving at velocity, and so they expand the most. So that's why air moves much faster in convection than water does. And so these air molecules are, when they get heated, they move at velocity. They don't just vibrate, so they float up. Gravity pulls the colder air down, and that creates wind. All of the wind on our planet, remember that diagram I showed you here? We would not have wind on this planet if we didn't have hot air rising and cold air falling. That was another thing that I thought was really exciting about what I learned in teaching this class. And so if you go inside of a building and allow the warm air to rise and the cold air to fall, like cold air coming from the ground, or from an atrium, you can get free air conditioning. You can get free movement. So basically what happens in this building is that at the start of the day, the building is cool because they captured cold air from the nighttime. But during the day, people and machines generate heat. And as the sun shines, heat is absorbed by the fabric of the building. and the temperatures rises increasingly, but not greatly. But in the evening, when the temperatures outside drop, the warm internal air is vented through the chimneys. You see the chimneys on the top of that building? So that's sunshine on the left, nighttime on the right. And so all that hot air convects through the roof. And this passively cooled building uses only 10% of the energy that's used by similarly conventionally cooled buildings. So this is a building in Hara, I can't pronounce it, Hara, Zimbabwe. It was designed to be entirely cooled by natural means. It's the first building in the world to use this natural process. And it actually provides parking for 450 cars as well. So that's the inside of that shopping mall. So inside, hot air rises, cool air falls, and they get natural air conditioning because they capture the cool air at night and they release the hot air throughout the day, or store it and then release it throughout the day.
I mean, this is like truly amazing, guys. And if you Google how you can make a homemade air conditioner out of some recycled kind of plastic bottles, I will find that link and put it down here for everyone. But again, guys, mimicking nature. We are basically saying, hey, look at I mean, who would look at a termite mound? Those things freak me out.
The
But no,
termites
let's
freak
take a
me out.
deeper look and figure out how we can create our own air conditioning. It's fantastic.
That's right. And it can be beautiful. I mean, it even looks better than the inside of a termite mound, right? Okay, so this is, I've just got a couple of 2 or 3 more slides left that just kind of remind us why we were talking about this today. Remember, everything that we saw that was amazing, even the front of that train that copied the face of a bird, is just a superficial resemblance because nature is so much smarter than we are. So if we can approach innovation and seek solutions that emulate the intelligence of nature, we're going to replicate cheap and free and less costly ways of surviving on this planet. And that brings us back to the image that started Earth Day, or that helped to create a more purposeful vision. I mentioned the termite mound earlier. A scientist, a biologist by the name of E.O. Wilson, found out years ago that there are some species like termites and ants and humans that actually will sacrifice themselves for the larger good. When they put chimpanzees and kids in different labs and they put 2 chimps together and gave them an opportunity to share food, the chimps attacked each other, but the kids shared the food. That's the difference between some species and our species. Our species have the ability to share, to cooperate, to work together to make our planet better. And we have the intelligence to come up with that superficial resemblance that will save us. All right.
Ah, fantastic, Dodd. If you will stop your screen share, I'm going to go to the larger group here and we will take questions. I'm sure you guys have some questions out there. So, all right. All right. I see you, Seth, over there. I'm coming to you, Seth. What's your question there, sir?
What's beyond space?
Oh, what's beyond space?
Oh, that's a great question. Well, I wish an astronaut was here, so I'll give you kind of my superficial resemblance of an astronaut. speaking of mimicry, but space is constantly expanding. You know, isn't that crazy? So what's out there is new space. You know, it's constantly growing. So there are. We really don't know specifically what's out there. We know there are suns out there that are hundreds of times bigger than our suns. There are planets out there that you know have the characteristics that might support life, but we've not discovered life anywhere else. We know from using things like the Hubble telescope that we can see all kinds of other systems that look like our solar system, but other than that, we don't know very much about the specifics of what we have here that might be replicated somewhere else.
And I think it's such a great question, Seth. And again, this is why I love science, because again, I would never stand in front of you and say, oh, I know exactly what's out there. We still don't know. It's like in many ways, we just have started to wrap our heads around what the heck is going on with dark energy and what is that. So beyond space is more space. And what's that's filled with will only, our knowledge of that will only grow as we explore more out there. But here's what's an amazing statistic as well. We've explored space more than we've ever explored our own oceans. So there's also some time to reflect back inwardly and see what we might discover there as well. But I love your question
Amen.
and keep thinking like that. All right, coming down here to Jack Grippo. I also see you, Tiago. I'll be over there shortly. What's your question, Jack?
One of the seven ancient wonders of the world was the Hanging Gardens of Babylon. Did we get the idea from them? Sort of.
I would argue that they got the idea from the earth, but we probably did. We probably were inspired by that. You know, the Book of Solomon in the Old Testament says there's nothing new under the sun, right? So we're just copying what we see. We're hopefully we're mimicking and emulating what we see and understanding how it works underneath that layer that we see with our eyes. And that's I think that's the lesson for you all as future professionals. If you will do your math homework and read on a regular basis and really ask really thorough questions to like you're doing today in your classroom when it feels kind of boring, if you'll kind of give the teacher a little extra energy and ask them why that kind of thing works the way it does, even on a day when it feels boring, you might pick up something that will give you that design insight that's going to change the world one day.
Absolutely. Jackson Wirtz. What's your question, sir? What's your
Would
question?
it be possible to use cold water and turn it into air?
Well, the planet actually does something like that. Cold water in our oceans sinks, warm water rises. The surface of ocean water, of lakes, of rivers that's exposed to the sun actually is heated to the point that it's evaporated and that it becomes a vapor, a gas, which mixes with different components, which is one of the components of air or of our atmosphere on this planet. So technically that's true. I think that's excellent thinking. You know, that's the kind of question that probes new ways of looking at something, you know, new opportunities that haven't been tested. And so I want to highly encourage you to keep thinking that way, keep asking those kind of questions.
Jackson, you're a great scientist. I cannot wait. I hope I get to see you this summer. Let me come over here to Tiago. You had your hand raised, and Tynan, I love your comment down here. But Tiago, what was your question, my dear?
What did the people when they put the grass on the building, did they order some, did they like order plants, or did they like just put like some different kind of grass on it?
I think I love where you're going there is like, did they order something or did they keep it natural? And I will tell you, here in Tennessee, we've got a great advocate named Mike at Grow Wild Nurseries, who's all, and this is, I learned this also from Professor Dodd, who says, plant native to where you live. So is that true on most of these buildings? Do you think they're planting native plants that are used to the environment that they're that the building might be in?
Sometimes they do. I'll have to say often they don't. And
Really?
yes, you know, we as humans still have the tendency to do what we're used to doing or to do what's easy. I see someone nodding their head up and down. For example, when we built the Music City Center in downtown Nashville with that amazing hourglass shaped It's like 3 hourglass shaped green roofs on the top of that sloping building. They used different types of sedums, which are fundamentally, as I understand it, they're sort of a desert type plant. And they did it because it was cheap, because someone had already manufactured a box system that a medium of soil and these plastic boxes that they could easily place on the roof and link together to create a green roof without having to do a lot more work to emulate a mountaintop with soil on top of it and plants on top of it. It was easy to install. It was cheaper to install. And I understand they've had a really hard time keeping it alive. And part of the reason they was doing it was they thought the roof would be hotter and would emulate a desert. So it would have been much better if they'd done like what Mike Berkeley has taught me when he did his green roofs. Go out and look at a local mountain, and look for a local mountain that's up high in elevation, that has very thin soils, and see what kind of plants are growing there. Well, what's even more important than the physical characteristics of that mountaintop are the what's inside those plants. Those plants have genetic material that has been tested through multiple climates and multiple harsh weather events and multiple pests and multiple different kind of nutrient cycles, where they had lots to grow with and very little to grow with. And so they already have the genetics of success built within them. So when we choose a native plant that has already been field tested here, we're choosing something that's going to survive, but that also has to be related to its place where it survived. So one of the biggest mistakes that I see people make when they're designing green roofs or even a rain garden is they don't pick the plants that like that type of place or that elevation, in the city. And so it's sort of a multi-dimensional opportunity. I need to pick a local plant that likes the type of place that I'm emulating on top of my building.
That is such a great thing to remember, because here in Tennessee, we go from super rainy seasons to super dry drought seasons. So this is something else I learned from Mike and Professor Dodd, is that what we want to do is we want to pick native plants who go, we've been around here for hundreds and thousands of years. We're going to grow because we have used to lots of water and no water. Maggie, I see your hand being raised. Let me come over there to you. And Lucas, I see you, buddy. Oh, pal, I'll be there in a moment. All right, Maggie, what you got?
So when they plant the plants on the walls, are they sustaining, or do they need to be watered all the time?
Yeah, they probably need to be watered. Did you finish your question there, Evie, or Maggie? I'm sorry if I interrupted you there.
No, I'm good.
Okay. And what's your name?
Maggie.
Maggie. Okay. Is that Evie next to you?
Yeah.
Or Evie? How do you pronounce your sister's name?
Evie.
Evie. Okay. Evie and Maggie. Okay. Welcome. Yes, they probably do have to water them, because remember when I said earlier that this emulation is kind of a weak resemblance of what nature's doing. So we're not as smart as nature. So when we copy nature, or when we better yet, when we emulate nature, it's hard to replicate everything that is natural about that condition. So yes, I've seen them actually with these big wands that are this real long pipe with, watering the side of the building. They also have built-in irrigation that drip water into each of those plants and help keep them alive. And I dare say a lot of the plants that were on the side of that building were probably not even native to Paris or even native to France. It has a lot to do with the company that manufactured the system of wall coverings that could be installed economically. And so therefore they probably have to maintain it with some very artificial means. So, and that's often true of some of our early innovations, where we often go with what we've got and then we improve it over time, just like nature does.
Evie, did you have your hand raised too, Evie? All right, let me unmute you. There you go. What was your question, Evie?
I was wondering, can you is it hard to get the soil up And like, would the rain wash the soil away when it's on a wall?
Yeah, that's a great question. I took a close-up of the wall with my daughter, and there were parts of the wall where the soil had kind of washed away, or maybe somebody had sprayed it too hard when they were watering that day, or maybe the box or the material that was kind of holding it on the wall wasn't manufactured properly and it kind of gave way. So yeah, I did see some of that, and that's why we say that our emulation of nature is imperfect.
Fantastic. All right, Lucas, what is your question over here, buddy, pal?
It is. Other shopping malls and that one mall that's used that in Africa. Other ones in Africa. Other than that.
If there are, I'm not aware of them. One thing that's funny about being an adult is that a lot of us adults are so used to doing what we've always done. And if you're running a business and you can make money fast as opposed to making money slow by designing something you've never designed, it's really hard to do unless it's a personal challenge to you. A lot of us adults take the easy way out. So it's very true that these things don't get replicated as fast as you think they would. They're amazing ideas, but often they're done by very, very dedicated, hardworking people. And so that's why we need more people out there like Mr. Elon Musk, who are willing to devote their former fortune to invest it with a lot of risk in something new to make society better. Some adults are just not wired, to make the world better because it's just hard. And so that's partly why we share these examples. We're trying to inspire other architects and engineers, and we're also trying to highlight the consequences so that more people will see the benefit of not just doing what's easy.
Great, great, great. All right, Tapa Swinney, I'm coming to you. What's your question?
I actually have two questions.
Sure,
the first one is that will we ever be able to predict the earthquakes before they happen? And what makes the earth have gravity?
I missed the last part, Tapa Swinney. Can you say that?
Something about mitigating earthquakes. And then what did you say about gravity? What makes the
earth have gravity?
Oh yeah. Okay, the first one is yes and no. Because of that superficial understanding that we have of the surface of the earth, and because we don't have the technology to drill down into or to enter the earth to see how these functions work, we have to make intelligent guesses. So there are some cases where we have monitors and detecting devices out there that can detect some of the early signals of an earthquake. And sometimes we just can't afford to have enough monitoring stations out there. We don't have enough money, or we're not willing to put enough money out there on the ground to detect earthquakes ahead of time. One example of that reminds me of how little we know is that when we had the earthquake out in the Pacific Ocean that created the tsunami in near Fukushima, Japan, they designed everything on the coastline with flood walls that were tall enough for all of the historic tidal waves, but they didn't realize that the entire coastline could subside during an earthquake because you had one plate sliding under another out there in the middle of the Pacific Ocean. And so the earthquake was created by these plates slipping, by that pressure that was building up over hundreds of thousands and maybe even millions of years. And it slipped. And when it slipped, the plate that Japan sits on went down. And so the entire coastline dropped anywhere from 3 to 7 meters. And so that allowed the tidal wave to go over their flood walls. Isn't that fascinating? So yes, sometimes we can't even detect how the land is going to behave after an earthquake because we don't understand it very well. or maybe somebody didn't study geology well that day. You know, maybe they slept late instead of going to the lecture about earthquakes and tectonic plate movement. But as far as gravity is created by mass. So the larger the mass, the more gravity is created. I can't give you a very appropriate definition other than some planets have enough mass to have enough gravity to form an atmosphere. They pull gases towards it and hold that. The smaller planets do not have atmosphere because they do not have enough mass to create enough gravity, enough pull towards the center of that planetary geologic mass that their atmospheres are essentially just stripped away. So gravity is determined by mass, by the amount of material that's there floating in
You
space.
can think of gravity as this invisible pulling field, kind of like, it's like, you know, and we define what we have here on Earth as 1G, right? And that just gives us that measurement. But you can take a look at the work from far back from Galileo to Henry Cavendish, who really gave us an accurate value for the Earth's density. He basically had this weird kind of like almost not outhouse or basically this, I guess, shed where he was kind of trying to do the calculations of actually how heavy was the Earth. And it's basically has about 26 zeros that follow. So he gave us a very accurate calculation. You'll read up on Henry Cavendish, but the unfortunate thing is that Henry did not think very much of women and their ability to understand science. So he would not have ever gotten into a conversation with us, but he did what he helped to describe. He kind of stood on the shoulders of giants, from Galileo to Newton's versions to Cavendish's, you know, evaluation of the Earth's density. So again, the heavier the object, the more mass, the more gravitational pull, the lighter the mass, and everything, the less gravitational pull. And it's like, as two objects are further and further apart, the less the gravitational force, the closer they are together, the greater that is. But it's fascinating to read about it, especially as we discover more and more about quantum physics and how, like, we kind of leave some of Newtonian physics and go into the world of quantum physics. And again, mind blown. But Tapa Sweeney, you're going to be one of my Nobel Prize. You guys are probably all going to win a Nobel Prize, and I'm going to feel really proud when that happens. But I know for a fact that Tapa Sweeney, you have that in you. So any last questions that we have for Dodd before we go? Here is kind of like your assignment for the day then. I put into the chat, let's see, Artemis, why don't you ask this question? I'll let you ask the question before I give them their assignment. I just saw that. Dodd, this is my great friend, Artemis Westenberg, CEO of Explore Mars Europe, and a fantastic educator, you know, a brilliant mind. You guys would enjoy each other's company very much.
I saw her nodding her head earlier. That helped me a lot.
Go ahead, Artemis.
Yeah, the thing is, lots of stuff that Dot showed you, you know, how we mimic Earth and how that helps us. Part of that has been government issued buildings in the Netherlands. Not as smart as this, you know, this shopping mall in Africa. We really should do something about that. Really do things like that. But putting, you know, sediments, putting a certain type of short, easily grown in our climate plants on top of our roofs, on our flat roofs, has been, you know, one of the aims of the government, and they're not paying for it. They're just showing you in television series, you know, how to do it. And then they expect people to do it, and they expect, you know, Home Depot kind of shops to sell it. And it actually is taking off enormously in the Netherlands, and it will insulate your roof so well also. In the Netherlands, it can really, really, really rain. And then, you know, you need some place to keep all that water. So like what Dot was showing us with these stones on the parking lot that would, absorb the water, so you wouldn't, have to use a canoe to get from your car into the building. That's one of the things they have been looking at for many, many years, because I know my country is very famous for its dikes, and everyone is always talking about the dikes, and actually interesting. But for me, what's much more interesting is that my country is really well into the dewatering and keeping the water level equal all year round, whether it rains very hard or not, and having a whole pump system so that the grass will stay green in the meadows, so the cows can eat something, but not too wet, because cows are not water cows. Cows are land animals. And so these type of things. So all these things, what he showed you, actually you probably could do, in your local shed, at home. If you have a shed, talk to your parents, because there are easy systems to put a roof on that, like that, and it would help to retain water for your neighborhood. It would look very, very nice, because it's not just green plants, they will also flower. It's really a really nice thing. It will be great for the bees, and we all need bees for our food. So that's one of the reasons why, when the government says, please do this. And also, it will, like I said, it will insulate, and it will keep the rainfall, and the whole, if there is water in your garden, if it's retained in a roof like that, it actually, if it's very hot, the garden will still feel cooler because of the water that's evaporating, because that's one of the systems in air conditioning work. So there are many, many ways that if we can mimic Earth, we should, because Earth is very smart. And like Dot told us, she is 4,550 million years old. She has figured out some stuff. We are still, trying to figure out. So listen to Earth and try her. So, that's one of the things that I loved about this. It's things we can try at home. It's like, years ago in the Netherlands, we found out that if we have highways and we have deer on one side and on the other side of the highways, they will try to cross. And you will drive into them and you will kill them, and you even might be killed yourself, because, some of these animals are really big. So what we invented was something really silly. Most of the people thought. We made a bridge just for the animals. It wasn't for human beings. It was just for the animals. We first built one, and now if I drive down on highways here, I find more and more, and some of them is not a bridge. We have dug tunnels under our highways so that other animals that are smaller will just, tunnel under these, man-made tunnels that are already ready for them, so we can preserve not just us, but also nature, and that includes the animals. Again, animals do use tunnels to get from one place to another, so we mimic that. It's the way to do things. Dot, I loved your speech. I learned a lot. I mean, there's still things that, we need to get into more. And I propose that, in one of these lectures, we will ask a friend of mine who is who's working with NOAA. So he knows all about tsunamis. He lives in Hawaii, and he also works on the Hawaii volcano. So he could tell us a lot about these things. And I know he's a great educator. And I'll ask him to.
Please do.
That
Yeah.
sounds great. And in
tell us
your
more about this tsunami, because it's one of these things we need to learn more, especially if more water gets into the ocean, because Greenland is really thawing, it's melting. And that's a lot of water ice on Greenland. That's more than a mile high.
And Artemis, do you see my virtual background to honor your mention of the wildlife bridge? I just happen to have that as one of my virtual backgrounds.
It's just, that might be the oldest one, and there are many now, because it made sense. I mean, it worked, and it was first we thought that was a lot of money to spend just on animals. But on the other hand, the earth isn't just for us humans. We share it with animals, and it's a bit, it's not a nice way of looking at the place where we live to say, oh, it's just for us humans. We don't care about the frogs or the deer or, or any of them. any other animal, we should share. I mean, in the end, it will help us. It's part of the mimicry, because, you know, it's part of this whole ecology that is our planet Earth. And, you know, investing like that, it always sounds like a lot of money. But for a government, I mean, for you and me, sure. For a household, it would be too much money. But for a government, it's just, you know, what you find important, you spend money on. And we voted that this is important. And now with the coronavirus and everyone staying home and the planet suddenly being, you know, my skies haven't been this blue in years. Not because the weather wasn't nice, but because the pollution isn't so bad at the moment. It's really much bluer skies. It's really lovely weather. The last few weeks here in the Netherlands, amazingly, nobody can go out, so it's not raining. It's like, who is thinking of these things? But, so anyway, that's how it is. But, you know, all these things tell us that perhaps even in this horrible time, you know, that we all have to stay home and that we are afraid that some of the people that we love, you know, your grandfather or your grandmother or, you know, even the neighbor might get ill, and really ill, not just a bit ill, but really, really ill. And we are worried about that. But in this time, the planet Earth is also telling us that we actually, if we don't pollute as much as we do, she's feeling better, which means it's better for all of us too. So I think we need to rethink, you know, how we live and how we use this planet and use this moment, these months that we are now at home instead of, you know, being wherever we want to be, to think about Earth and use it more wisely, because she's showing that it can be done.
Absolutely. Tiago, you had one more question, and then we will close out with some things for you guys.
I did. So last question. Why did how many things did they build for the animals?
Oh, how many like different ways of like protecting them while they were building other things?
Yeah.
I don't know about in the Netherlands, and it's like I know that there are certain places in the US that we have like animal crossings, and we started to think more about, okay, this is a good place, as Dodd was telling us, to go underneath things and give those animals things. I will tell you that the growth of Nashville recently and its outer areas, that I have been lobbying very hard that their green spaces are considered when we're building new housing developments. Because here's what's happening. Any given morning this spring, we had 40 turkeys in our front yard. I think they were eating a lot of our plants and grasses, which was fine. I would actually, when it was really the harder, kind of like colder winter, I would kind of throw out some like feed for them. We're also seeing deer who are displaced because we've taken over their homes. And so this is something for you guys to think about as you become maybe environmental engineers and go, when we build a place, much like that beautiful place in Georgia that was able to build a really great community and spare their forest, spare their trees. We are one of the houses in our neighborhood that it's like, we love our trees. We are not going to cut any of them down. We kind of trim them back so they don't fall on our house someday. But we've got neighbors up the street that mowed down all their trees, and it kind of like, it nearly makes me cry. I'm like, no, we need the trees, right, Dodd?
Actually, in the Netherlands, it's forbidden even to mow over my own tree.
Really?
When my daughter was born 26 years ago, my brother gave me a really small tree to put in the garden, and you should see a picture of it now. I can't reach around it. It's really huge after 26 years. And if I would want to take that tree down, although it's in my own garden and I have planted it myself, I'm not allowed to do that. I have to ask for a permission, and I better have a good reason, because, you know, we need our trees. They're our lungs of, you know, for our air. So we're not allowed to just mow them down or just take them out if we don't like the shadow of it. I mean, we need to think about things like that. And if we think about things we can do, all of us, is some years ago, I bought this really small kind of, it's a kind of a little house, very, very, it's not very deep. It's very, and it's, like I said, it's only this big. And it's meant for bees to rest while they go around. And I hooked it up in my garden, on my garden wall. And I, for the first time, a few months, I thought, this is really useless. I don't see anything. I mean, it looks kind of funny, but that's all, Now that it's more restful at the moment, of course, not as many trees, not as many cars, not as many people on the street. Actually, my garden is buzzing. And that little, what we call a bee hotel, is actually, being used. And so perhaps it needed to be weathered a bit more than just fresh out of a shop and, smelling like people. I don't know. And perhaps it's because, it's all more quiet at the moment, but I actually have no idea. But what I do know is that a thing like that, there are models on the internet where they help you to, build it yourself, because it's not really very complicated. And you could put one or two on the side of the house, or, on the side of the garden wall, and try to, make it in a nice place, not with the full sun on it, perhaps. Things like that. You can build them yourself, and small things like that already help our earth. And that is something all of us can do. It's not very expensive. It's not very, very difficult to do. I'm pretty sure one of your parents, if they have some extra time, will be able to help you. And perhaps you can even, figure it out yourself. And perhaps, when the schools are open later this year, you can ask your teacher to make it a project in the school. Because if we do that, and we know, and everywhere on this planet, we really need our bees, it's a small thing we can do, an easy thing.
Awesome. Dodd, any last things before we close out today that you want to say to all of us?
Yeah, I just want to encourage you to all of you to keep exploring nature. There's so many things that haven't been discovered. All of you all have such bright minds. All of you asked wonderful questions. That the reason that we poorly emulate and we come up with a weak resemblance of what's really there is because we haven't spent enough time exploring it and understanding it. Like Janet said, we know more about space than we know about our oceans, for example. So sometimes what's right in your backyard, what's right in your neighborhood, what's in your community is the most important thing you can know. And I think that's going to become more and more important over time, because if you think about our neighborhoods, the way wildlife thinks or exists, they live in ecosystems and niches, those realized niches, those compromised homes and neighborhoods that they have created for themselves to survive are going to be the same lessons that we can learn if we'll look locally. So I want to encourage you to think locally as you think about opportunities, and look for solutions that have already been defined. You don't have to go to Europe, and you don't have to go to Australia to discover great things. You can discover them right in your own backyard, because your place is special, primarily because you're in it, and your future is what that place can provide for you.
Thank you so much, Professor Dodd. So here is your challenge and your quest to celebrate Earth Day today. If you can, and I know some of you may or may not be able to, but if it's possible, I want you to go outside and I want you to observe. I want you to listen, get really quiet and see if you can listen to the birds. Can you even maybe take your camera or your phone outside and take some pictures, and then determine, wow, I know for ourselves, we actually have a hawk nesting in our backyard. We've got bluebirds, we've got doves nesting. So we've got chickadees. We also put out lots of black oil sunflower seeds. So go outside. Also start looking at your plants. What is this? Do you know that we drive our neighbors crazy? Thank goodness we don't live in a homeowner's thing. But it's like in the springtime, we actually leave. I learned this from Professor Dodd. We actually leave a whole section of a middle upper yard just as wildflowers. It helps the bees. We love what it looks like. They come up naturally. Why do I want to mess with nature? It's doing a beautiful job. So go outside, observe, and I want you guys to tell me tomorrow 5 things that you found in your very own backyard that you either want to see more of, or that you're going to put some bird feed out, or you're going to try to build your own bee hotel. Find out those things. You can even do something as simple as making a butterfly garden. And I will leave you to Google that and find that out. I left directions for you too, if you want to figure out how to harness the energy of the sun on Earth Day and build your own solar oven. You can bake some cookies pretty darn fast in your own solar oven. You can take an old pizza box, but Google that as well. So 5 things tomorrow about how you're going to protect what's in your own backyard. And I will see you then. Let your mind revolve around this thought. The universe is always expanding. Let your mind do the same. And that's the view from Janet's planet. All right, I'm going to unmute you guys and say thank you, Professor Dodd.
Thank you, Professor
Professor
Dodd.
Thank you.
Professor Dodd.